from welcome to Pharmacognosy practical. Right? So today we are supposed to learn about determination of vein islet and vein termination number. So this will be in the practical included for the pharmacy second year and second sem. It is determination of vein islet and vein termination number. So whenever we enter into a practical, right, so definitely we would have an aim. There are some requirements, then which will be followed by a principle that is involved. Then we go through the procedure. Then we would have an calculation part, and finally we would like to report what we found. So coming to the aim of our experiment, so as the experiment title is that we are supposed to determine vein islets and vein terminates of any leaf sample. So our aim would be that to determine vein islets and vein terminates of given leaf sample. Generally this is determined in leaf sample in 1 square millimeter area. So this is our aim. So as our aim, it is including that we are supposed to determine vein islets and vein terminates in 1 square millimeter area. So please keep it in mind that it is only 1 square millimeter area. So for tracing vein islets and vein terminates in 1 square millimeter area, we use special type of apparatus called stage micrometer, eyepiece micrometer for tracing, and for identification of the leaf constants we use a microscope, then followed by a glass slide. Then we use for clearing the chlorophyll, we use chloral hydrate solution, we use a cover slip, and for tracing of such images again a special type of apparatus called camera lucida that we use. So these are the minimum requirements that we need for determination of vein islets and vein terminations. So coming to the principle of the experiment, as we are dealing with this vein islets and vein terminates which are called leaf constants, right? The term leaf constant, it indicates generally it is involving a qualitative and quantitative microscopy. So in case of qualitative, you are supposed to identify vein islets and vein terminates present in the leaf sample. At the same time, you are supposed to determine quantitatively, that is number of vein islets and number of vein terminates again in the same given leaf sample. So since it is involving qualitative and quantitative microscopy, so as it is falling under the leaf constant, since we are using a leaf sample here and the values are said to be constant as long as the leaves that we collect from the same kind of plant and same kind of species. So when a plant belongs to same genus and same species, definitely the leaf sample which is collected from such plants, it has got the same values which are mentioned already in the standard books. So as it is a leaf constant, definitely that would not change, and there will be a range of vein islets and vein terminates. So in order to determine this the range of vein islets and vein terminates, first let us see what are called vein islets and what are called vein terminates. So for example, see that this is a leaf. Generally the structure of leaf that we see is due to proper venation, right? So the structure of leaf which is broad or which is short or which is small, generally we call it as the spreading of venation. So as the venation is spread throughout the leaf, definitely the size of the leaf would be larger. The spread of venation is less, the size of leaf would be also very less. So apart from these veins, generally venation, so where the veins are incontinuous like that, so whichever they are spread throughout the leaf starting from the midrib to the margin of the leaf, generally we call them as vein islets. So from these vein islets, so there are some vein terminates where they have terminated at certain point, right? So vein islets are those which are incontinuous, arising from the midrib and where it reaches the leaf corner, right, leaf edge. Or else if the vein terminates, they arise from the vein islets or else from the midrib, and they used to terminate at some point which we call them as vein terminates. So now we are supposed to identify these vein islets and identify those vein terminates, and we should measure them, how many vein islets and vein terminates are present, and you should trace them in 1 square millimeter area, and by using a special type of apparatus, that is camera lucida, you are supposed to identify how many number, and we have to calculate and report which are present in 1 square millimeter area. So as we know that the concept of vein islets and vein terminate determination is that to determine the genuinity of the leaves. So generally we have number of leaf samples available in the market. So to determine whether the given leaf sample is genuine or adulterated, right? So after seeing the leaf, generally we go through the organoleptic evaluation, right? By seeing the characteristics like its color, its odor, its taste, its size, its shape, right? So not by these external features, but when you wanted to confirm the leaf for its genuinity, generally we go through the microscopic characteristics. So in case of microscopic characteristics, as we have transverse sections and longitudinal sections, apart from all those, in continuation to the microscopy, so we have a separate method for determination of leaf constants. Among those methods, first we used to determine number of vein islets and number of vein terminates which are present in 1 square millimeter area. So coming to the procedure, what shall we do? So in case of procedure, generally the leaf sample that we collect. So the leaf sample generally which as we collect a fresh leaf sample which is green in color due to the presence of chlorophyll. But for identification of vein islets and vein terminates, if it is green in color, we may not be able to identify. So for removal of such chlorophyll, generally we add a special reagent called chloral hydrate solution. So chloral hydrate reagent is a reagent which clears leaf, that is which clears chlorophyll and makes the leaf transparent. So when this leaf is said to be transparent, definitely we could identify the number of veins and number of vein islets present in its leaf sample. So after addition of this chloral hydrate, where we will get the leaf sample. So for this, generally this is boiled by using a heating module or by the flame at 60 degrees centigrade, where the boiling of boiling of leaf with the chloral hydrate, where it is going to remove chlorophyll. Since chlorophyll is removed, where you could see there are transparent leaf cuttings, right? Where leaf is made into small pieces, boiled with the chloral hydrate, then this chloral hydrate it is removing chlorophyll. So where you will get the transparent leaf portions, and these transparent leaf portions generally we go for transferring onto a glass slide, then covering it with a cover slip, and it is supposed to be focused under the microscope, right? So this is the general procedure. But as we are supposed to determine this in 1 square millimeter area, see for example, assume that this would be a square which is of 1 millimeter area. So coming to the practical, generally 1 square millimeter area which will be very short, right? So when it is said to be very short, it is impossible to trace the images in this 1 square millimeter area. So therefore we are supposed to go for a procedure called extension of squares. So where 1 millimeter square can be extended into a larger square by using stage micrometer and eyepiece micrometer. Since the sample is placed onto the stage, right, and we use eyepiece micrometer for tracing the images generally. But as of now, we don't use these two, but these two are utilized to extend the square. So for extension of squares, as we are using the stage and eyepiece micrometer, so there is a simple calculation that we should know about this. So if it is a stage micrometer, generally stage micrometer is a micrometer device which is provided with a scale divided into 100 divisions. So when it is divided into 100 divisions, that is scale, that is stage micrometer, So this 100 divisions, which is equal to 1 millimeter area. So when it is equal to 1 millimeter area, the same scale can be traced by using camera lucida, and you can measure the distance between these. So when you wanted to measure the distance between these, definitely the stage micrometer can be placed onto the stage, and by using a camera lucida, generally here we use is mirror type of camera lucida, where the image of stage micrometer is focused onto the black chart paper which is fixed to your board. So after tracing the 0 to 100 divisions, then which is traced on the black chart paper as 0 to 100, that is these two divisions can be focused and traced. So after focusing this 0 to 100, you are going to draw two lines with 0 and 100, and you can measure the distance between 0 to 100 by using a normal scale which you get it in centimeters. So as you get it in centimeters, the same can be drawn on a black chart which is related to 1 millimeter area. Right? So we are nothing doing here. So we are not at all manipulating something, or we are doing nothing. Just because that as stage micrometer which is divided into 100 divisions, and these 100 divisions which are equal to 1 millimeter. The same micrometer scale, it is traced onto a paper by using a camera lucida. So when it is traced onto a paper through the microscope, definitely you could see that the distance between these 200 divisions is more, and which can be measured in centimeters. So once it is measured in centimeters, so in practical generally as it is 1 centimeter, in a general way, generally where this is set to be a standard scale, definitely you will get it in centimeters. So approximately it may be below 10 or above 10. So I am taking a standard value as 10 centimeters. So now after tracing it by using a camera lucida, so what do we understand here? So in case of stage micrometer, where 100 divisions, which is equal to, you are supposed to focus number of V islets, you are supposed to focus number of V intermediates. By using the same procedure, that is by using the camera lucida itself, you are supposed to trace the images. But for our convenience, as 10 centimeter area which is larger, and as we cannot trace the image on the complete 10 square millimeter area, for our convenience we are dividing the square into 4 equal squares. And now you can trace your image onto the first square, and the extensions or V islets which are spread to the second square, let them, if some they may be extended out of the square, some may be extended to the below square, some may be extended to the other squares. So let them extend to the whole to the square. So while drawing or while tracing, you should see that the images whichever they are traced as V islets and V terminates, without disturbing the microscope, without disturbing the image, you are supposed to continue throughout the process until unless your complete square is filled. See, once you draw, you could see that there are number of V islets, there are number of V terminates which are spread throughout the squares. So in this manner we may get it. So this would be a sample. So after drawing complete square by tracing with camera lucida, then now you are supposed to count how many number of V islets are there, how many number of V terminates are there. So as we have divided into 4 equal squares, so first let us consider one square individually. So this would be the first square, this would be the second square, this would be the third square, and this would be the fourth square. So when it is on first square, so let us see that there are number of V islets, 5 V islets. In case of V terminates, it is 1, it is 2, this is 3. So there are 3 V terminates. And if you go with the third square, 1, 2, 3, 4, 5. Again 5 V. So when you are counting with the last square, where we got V islets of 4 and V terminates of 2. So now what shall we do? We see that the total number of V islets and the total number of V islets, These vein terminates which are present in complete square. So as the square which is equivalent to 10 centimeters, which was traced from the stage micrometer, which is equal to 1 millimeter, and now this 1 square millimeter, it is equal to 10 centimeter, which is divided into 4 squares, and the total number of vein islets and vein terminates are counted here. So on an average, what do we get? 3 plus 5, 8, 13 plus 4, 17. So total number of vein islets are 17, and total number of vein terminates 2 plus 3, 5 plus 2 plus 2, 9, 7. So now the total number of vein islets are 17, total number of vein terminates are 9, which is equal to 1 square millimeter area. So now we should check the value with the standard reference. So what kind of leaf sample is provided to us? By saying the plant or by saying the tree, we could know that genus and species. But if the sample is unknown to you, so not all the time that you get your leaf from the tree or from the plant. So which is available in the laboratory, which is given in examination. Generally, so whichever the leaf it is, though you may identify it by its external features, but it should be confirmed as a genuine leaf by its microscopic characters. So in case of these microscopic characters, the initial step which is used to detect genuinity of the leaf is a leaf constant, that too in case of vein islets and vein terminates. So after getting this range of 17 of vein islets and 9 of vein terminates, which kind of leaf this would be, and what is the sample of the leaf? So coming to the report, when you are writing a report, you should report in such a way that the given leaf sample is determined for its leaf constant as vein islets, number of vein islets and number of vein terminates in square millimeter area are dash and dash. So the given leaf sample may be as so and so. Then your report gets completed. So this would be your complete practical. If you perform in your laboratory, as you need a number of apparatus, number of reagents, a microscope and a leaf sample. So as we have number of leaf samples, how do we choose a leaf sample? So whichever the values that are specified in our standard books. So it may be from your textbook or it may be from the standard reference books like formularies or pharmacopoeias, whichever that you refer. So where in case of pharmacopoeias or formularies, where the monograph of individual drug is given. So as the monograph is given, definitely we should see that the sample given is genuine, which is supposed to be used for further process. So if the sample is genuine, then only we can use it for further preparations or formulations which have good characteristics, which are stable, which are suitable and which are biologically important. So the selection of leaf is more and most important, as it is an initial step as we collect the fresh leaf sample for determination of these leaf constants. Then this fresh leaf, once you confirm that it is a genuine, then these fresh leaves you can go for drying, then you can make it into powder, then you can observe the powder characteristics. At the same time, the same powder may be used for further extraction process, isolation process, identification process. Then after identification of such constituents, then also such constituents should match with the monograph of the leaf sample that is provided. So all the parameters that we are coming across. And coming to the importance of this determination of leaf constants, it is as important as the other constants or the other parameters that we are studying under adulteration. So why we are talking about the adulteration? Because as the pharmacognosy, we are dealing with study of crude drugs. Crude drugs are those which are directly obtained from the plant or other sources. As they are directly obtained without any processing except drying, they may have some other constituents with it, they may have some other foreign matter with it, or else similar looking substances, similar looking leaf samples may be added to it because of its cost or because of its scarcity. So definitely there is a chance of adulterations, there is a chance of adulterated drugs that are available in our laboratory too. So first we are supposed to determine the genuinity, then only such samples can be carried out further. So in carrying out for further tests, further examinations for the leaf samples, this would be the basic microscopic analysis or microscopic evaluation parameter which is included under the detection of adulterants. So as the leaf sample, it is detected for its number of vein islets and vein terminates, and if this value is not matching with the standard leaf sample, then automatically you should come back and again you should start your experiment where the problem is. Whether the problem is with the tracing, whether the problem is with the identification of V islets, whether the problem is with the identification of constituents. So if the problem is diagnosed, then as you are repeating the experimental part, definitely you could rectify the errors. At the same time, you could accurately determine the number of V islets and V terminates, and this is compared with the standard sample. So what is the standard? Standard is nothing but whichever the value that is mentioned in the textbooks or whichever the value that is given in the monograph of individual. So if the value is matching with the monograph of individual, then the given sample is identified and it is reported as the same sample, then we could confirm that the given sample is genuine and it is not adulterated. So with this our experiment is closed. Thank you.